Okay, so let's see the fabrication of a transistor. Okay, let's see the fabrication of one NMOS transistor. So since now till now we are somewhat familiar with the steps and the things that are used, that will be used in the fabrication of ICs. Now I think you can very well understand these steps. Okay, so again, as usual, we will start with the silicon substrate. Okay, and then we deposit one silicon dioxide layer on the top of it using oxidation process or some other suitable process. Then this oxide layer is patterned to form this open window here, right? Okay, now this is a thick oxide layer, and on the top of it we form a thin high quality oxide layer. This covers the whole region including this open window also, and this thick oxide layer. Okay, and after this what we do, uh, we cover it with a layer of polysilicon. This polysilicon layer that covers the whole surface area including the open window over this silicon substrate. Okay, and this is patterned again using those photolithographic steps. Okay, I'm this is just showing the major steps. Okay, then what are the steps involved in photolithography, what are the steps involved in oxidation, those things are not shown here, right? So this is a kind of shortcut. So don't assume that this is just only these steps are required. No. Okay, so this after I have not shown here the mask also. Various masks are used for each patterning. There will be one kind of mask that will be used for patterning this. There will be one kind of mask that will be used for patterning this kind of window. So those things should be shown. Okay, but since you are aware of those things, I have this method, this steps does not show. But anyways, so this polysilicon layer is again patterned to get this kind of structure. Okay, now we have here this polysilicon, then this oxide, and then this semiconductor. So this is polysilicon is made to conduct, so this will act as a conductor. So it is like a metal in between oxide and then semiconductor. So this forms a MOS structure, metal oxide semiconductor, right? And look at here again, this is patterned, so we get rid of the unwanted polysilicon layer and we get the clear MOS structure here, metal oxide semiconductor. Okay, now after obtaining that pattern, the next step is to form the regions for source and drain by using which process, what processes. It can be formed by using ion implantation, right, or diffusion process. Fine, if you remember. So now two n plus regions are formed here. Okay, two n plus regions are formed here. Okay, and this will act as, one will act as the source of NMOS, one will act as the drain of NMOS. Okay, and this is the channel that will link the source and drain, and this will act as the gate between source and drain of the NMOS, right? Okay, so after this, forming the n plus regions for NMOS transistors, right, this is again covered with the insulating oxide layer on the top. Okay, oxide layer, it is covered. Then this insulating oxide layer is patterned in this fashion so that the gate material is covered with the insulating oxide layer, and this window is open, this window is open here, and this is filled with metal. This is filled with metal, all surfaces filled with metal. Remember the metallization step. Okay, so this is what being performed here. Okay, and then the metal layers are etched out from certain areas where they are not required. Okay, so for this area, for n plus, metal layers are required. This area for n plus, metal layers are required, and this will act as drain, this will act as source connection, right? And I think in the next step no, right here. Here itself I can explain. Okay, I will explain. So this will act as the source of the NMOS. This will act as the drain of NMOS, and this insulating layer will be etched out, and one connection will be taken out from this poly silicon material, and this will act as the gate of this NMOS. Okay, and you properly bias this to get a proper current flow through source and drain. Okay, so these are the steps to fabricate one NMOS over a silicon substrate, and basically this is taken as a p-type silicon substrate. Okay, so NMOS is formed on a p-type substrate, and PMOS will be formed on n-type substrate. Okay, so they are like opposites. So when you want to form a NMOS, you will start with a p-type substrate and vice versa, right? So once again, we started with the p-type substrate and we formed two n plus regions for source and drain, and in between we formed the metal oxide semiconductor structure. Okay, and this region will be the channel, will act as the channel that will connect the source and the drain. Okay, and these are the terminals for source connection, this is the terminal for connecting drain voltage, and this is the terminal for connecting gate voltage. Okay, so these are the steps for forming one NMOS structure. So now we will look at the fabrication of CMOS inverter or CMOS N-well process. Okay, now why it is called a CMOS? C is for complementary. Okay, note down, this is very hard to write here but again, this is complementary, M-E-N-T-O, I'm telling the spelling, complementary MOS, metal oxide semiconductor, right? Okay, why it is called a complementary MOS? Because this CMOS structure will contain the complementary MOSFETs. Okay, right. So what is the complement of NMOS? PMOS. Okay, and what is the complement of PMOSFET? One NMOS. So it will contain both. So look at here, can you identify that this is the substrate area, substrate material. Okay, now this is one n plus, this is one more n plus, so basically this will be the area for n MOSFET, right? And this is in between the gate terminal. Okay, so this area, and this is a channel, so this area will be for NMOS, right? And this area P plus and gate, this area will be for PMOS, PMOS area. Okay, so this P MOSFET is present along with N MOSFET on a single wafer, on a single substrate area, right? And then this particular structure is called as a complementary MOS structure, right? Okay, again we can have a look at this. This PMOS is formed in one N-well region, so we need to form one N-well, okay, before forming the PMOS actually, right? Okay, so we had started here with one substrate, and we will create one N-well for forming PMOSFET. Okay, and then let's say that NMOS is fabricated on this substrate itself, right? Okay, and again, why it is n-type? This should be p-type, this should be p-type substrate. Okay, so this is p-type substrate, this is n-type region, the p-type contains the NMOS, the n-type contains the PMOS, right? And this one P plus region is used for giving the connection to the body or bulk or to the substrate. Okay, and this N plus region will be used for giving connection to the N well region. N well region. Okay, so this is connected to VDD or power supply, and this is connected to the ground, right? The two drains are connected common, and this will give us the output terminal. Okay, and the input is applied to the common terminal between the gate of NMOS and the gate of PMOS. Okay, so the gates of two are taken common to provide the input signal. The drains of two MOSFETs are taken out common to get out the output signal. Okay, and then the source of NMOS is connected to ground. The source of PMOS is connected to the power supply VDD. Okay, so these are the main steps. Diagrammatically, you can imagine the things. So we start with formation of N-well regions. Okay, this is the N-well region required here, N-well region. Then define NMOS and PMOS active areas. So what do you mean by active area? Active area means the formation of those active layers. Active layers means those N plus or P plus regions. Okay, so this is the active area for NMOS, this is the active area for PMOS. Okay, so define the areas for NMOS and PMOS, the active areas. Next is to field and gate oxidations, thin-ox. Okay, the oxidation layers are required. We have seen in the formation of NMOS. Okay, the thin oxidation layer, the thick oxidation layers, right? Then form and pattern polysilicon. Then after the deposition of oxidation layer, we deposit a layer of polysilicon. This polysilicon layer is actually used for defining the location of gate. Okay, then P plus diffusion areas are done, N plus diffusion areas are done for NMOS. This is for PMOS. Okay, then contact cuts, the contacts are taken out. Okay, and then it is patterned with metallizations to take out the final terminals outside the chip. Okay, overglass with cuts for bonding pads, then these are taken out for the final contacts outside the chip to be joined with the bonding pads of the IC. Okay, so do I have, yeah, this is the diagrammatical representation of I think this is the fabrication of CMOS. Okay, this is also showing very basic steps, but still we can go through it. Look at this, substrate is taken. Okay, although it is starting with N substrate, but in most of the book I find it as a P type substrate, although it can be fabricated with N type also, no issues, but I prefer to start it with a P type substrate. No, in this case, sorry, I'm sorry. In this case, because this will be containing P MOSFET. Okay, so P MOSFET is done in N type substrate, right? But what was done earlier? Here N MOSFET was in N type. Now here it was it should be P type substrate, right? This is correct. This is correct. So starting with N substrate material, okay, and then pattern it with the oxide layer, form this window, form one P well here. Okay, so this is the side view, right? The thickness of this P well is around 4 to 6 micrometer. 4 to 6 micrometer. Okay. And when you look from the top side, it will look like this. The top area of the silicon substrate with this open window. This particular window is this part that's visible from the top. Okay. The next is to define the active region for the two uh, MOSFETs. Okay, so this is the active region for uh, NMOS. This is the active region for PMOS. Okay, so from top it will look like this: the active region, the active region. Okay, now this was well, P well, and P well will contain N MOSFET. Okay, so I might this is actually representing the mask. Okay, which mask will be used for forming the active region for P MOSFET and N MOSFET. Okay, and this particular mask, this particular is called as P tub mask, will be used for forming this particular N well area, and this Thinox mask will be used for forming these two windows. Okay, and now we want to form the gate location. And if you remember, the gate of NMOS and gate of PMOS was connected commonly to feed the input signal. Okay, so the mask that will be used for this called as polysilicon mask, and this will contain this window that is open here like this. Okay, why it is like this? Because this will uh, this is this is this particular, and this area is this particular. It looks like this from side. Okay, and these two has to be connected to a common point, and hence this is connected to this particular gate of NMOS. Okay, and hence, and that's why it is like in this continuous fashion, it is not disconnected. So this particular mask will be used for fabricating the gates of PMOS and NMOS. Okay, and this is what P plus mask. P plus mask will be used for forming the P plus regions here. The P plus regions will be done like this, and this particular mask will be used for forming the P plus to form P MOSFETs. Okay, and this P plus mask negative will be used for forming the N plus regions. Okay, so earlier it was P plus mask, now this is P plus mask negative. It means this is blocked and all are open, the rest of the area is open and this is blocked. Okay, after this the contacts are to be made. So there are four contact windows: 1, 2, 3 and 4. So where are these to be taken out? So look at this, the contact from this one, this one, this one, and this window is open, and hence there are four windows for contact. So this is the contact mask. Okay, and now this one last is the metal mask. Okay, that will be used for patterning the metals and depositing the metals. Okay, so we want to deposit metal here for taking out this connection on P, on this, and this drain and this drain was connected together to take out the common output terminal, right? And hence this is a common window between the drain of PMOS and NMOS. Okay, this one is the source of PMOS, it looks like this. This one is for the source of NMOS, it looks like this. Okay, so try to relate, so try to imagine that how would it look like from the top side. Okay, so this is the side view. Okay, and this mask is shown from the top side. When you look from the top side, when you look from the top, how would the mask will actually look like? Okay, so I think these are the steps that are used for fabricating one CMOS structure. Okay, CMOS means it will contain both NMOS and PMOS. Okay, so if you are starting with N substrate material, you will have to form first the P well. Okay, now N substrate will contain P MOSFET, the P substrate will contain N MOSFET, right? So look at here, N substrate, P MOSFET, and P well or P type will contain N MOSFET. Okay, and the shape of these various masks is a matter of imagination. Just try to use our imagination, and you will be able to relate this with the top view of these substrates, right?